If you want to get to 4 nines, this is what the investment is. Now tell me, would you rather spend the money on that or on something else?
This is DevOps Paradox, episode number 179. What are service level objectives? Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, you know how much I love all the three-letter acronyms that go with business, right? KPIs, SLOs. They just make me happy.
I love them. I get them every quarter. I ignore them the rest of the quarter, and then I get new ones.
Oh, and you just ignore them for that next quarter?
Yeah, because kind of
okay.
They exist. But it really depends on whether we're talking about KPIs or SLOs. I have different opinion on one or the other.
Well, let's talk about SLOs today.
Okay, that's better.
Today's show, yeah, because KPIs just make me sad.
That's because you don't ignore them. You're not listening to me, man.
Oh, right. Ignore them. So on today's show, we have Brian Singer on from Noble9. Brian, how you doing?
I'm great. Thanks for having me on.
And we're talking about SLOs today, service level objectives. If you're an SRE, you're probably familiar with the term. If you're not an SRE, or if you're not working in that space, Brian, can you define a little bit what an SLO is and the real pain that we're running into in trying to get SLOs implemented in organizations?
Sure. When I think about an SLO, I think about something that's telling me how much unreliability I'm willing to accept in a service that I'm supporting. So if we typically are expecting a certain number of errors, a certain amount of downtime, because nothing is ever perfect, the question very quickly becomes, how imperfect can we be before we're impacting the customer experience or customers are getting angry enough to leave? And the answer, I think, is somewhat surprising in that you can actually be pretty unreliable before customers notice. And SLOs help us achieve some level of, I would say, sanity in the work that we do as operators, because you have hard data to bring back to whoever wants to know when they say, well, how much downtime did we achieve 4 nines? And you can actually say, well, we actually met our SLO, which we all agreed on, product, sales, etc. And we did it without having to overspend on a ridiculous amount of availability just for the sake of having it.
It's interesting you bring up 4 nines there. We all agreed to hit 4 nines. We hit 4 nines, but our customers were still yelling at us because of the perceived outages.
Correct, because you're measuring the wrong things usually. If I measure the response time of how quickly my web page loads or whether it's available, that actually doesn't tell me anything about the customer experience of using that application. If you think about a banking application, for example, I don't really care how long it takes me to log into that application. I care that when I log in, I can see my balances, and that when I go to pay my bills, it doesn't take 15 seconds for the bill pay page to load, for example. So service level objectives help us get very granular in terms of defining what customer expectations are and then what we need to do to meet them. I like to think about, maybe I'm running an email application, for example. If it takes the user 3 seconds to load that email application from a cold start, he's probably okay with that, he or she or they. Whereas if I'm dropping a message on the floor 1 out of every 100 messages I'm just not accepting because I don't have enough throughput. Well, that's probably a really big problem. So we start to understand that users have different expectations about reliability depending on what they're trying to do and how much it impacts their actual goals. And so SLOs, again, allow us to get very granular in defining those things and actually make it so that we don't spend a ton of time and effort and energy getting to really high levels of reliability where it doesn't matter to the user, but we focus our resources and our effort on those things that do, because as we know, getting to 4 nines or 5 nines requires a significant investment. It requires typically teams of SREs that are 5 minutes away from a keyboard at all times. It requires hot environments, right? So it requires really significant investments. And many services don't need that. But then the ones that do, we should be able to measure that.
I really like what you're saying, because most of the people I speak with, they're overly concerned how to reach a certain number of nines, while what you're saying right now is it's just as important how not to go above certain number of nines, right? And I have a feeling that people are not putting sufficient attention to the latter, right? Kind of everybody is obsessed. If you ask somebody, how many nines do you want? They will say, what is the maximum number I can have? And that will be my answer. 17.
Yeah, and then how expensive does that get? And the other thing that makes service level objectives a really cool tool in our tool belt is the fact that we can define a service level objective to really match what the user expectation is. You'll notice in those 2 examples that I gave, in one, I was talking about how many messages out of 100 I'm actually able to accept. And in the other situation, I was talking about how long does a page take to load. And the reality is that reliability can mean wildly different things depending on what we're trying to accomplish in an application. I could be running a backend service and I'm serving internal customers. Maybe I'm running a database service, and for them, reliability is that the data is consistent within 2 seconds of them writing it, some percentage of the time. I could be working on a front end, and reliability is that when a user tries to log in, they get the homepage within 3 seconds. So you'll notice that I'm measuring very different things, but a service level objective reduces both of those or normalizes both of those to a percentage, right? What percentage of the time am I actually achieving that thing that I'm trying to do? And then it gives us a language to speak about reliability where everybody's on the same page. And that's why it's such a powerful concept.
One thing you said earlier is the expectation of downtime. How do you convince C-levels that it's okay to have downtime?
I usually start with a discussion around how much it costs to not have downtime. And this is something that we actually do as an exercise with folks that are implementing SLOs. But you start from the perspective of, okay, if you want to get to 4 nines, right? This is what the investment is. Now tell me, would you rather spend the money on that or on something else? And here's what customers are saying about that level of availability. Now, in some circumstances, you have to hit that because, maybe you are a trading application and it has to be, I've talked to plenty of users of SLOs where we're a bank and the amounts have to be correct. Every time they're not correct, I get a phone call, right? And so you have to have very high availability for that, or, extremely high objectives, we like to call them. But in many circumstances, the cost of achieving that does not reflect the benefit from having that level of availability. So then you break it down in terms that people can understand. Do you think it would be okay if 1 out of every 1,000 times a user had to hit refresh? Because if that's okay with you, I can save you 20% of the cost that we're spending to operate this service. And when you put it into those terms, starts to make a lot of sense to not pay for really high availability. And the reason it's so hard to achieve even 4 nines is because of the way that we build modern software and the dependencies we create between services. If I, have an application that fans out and has dependencies, let's say on 5 different services, and I want that application to achieve 4 nines, for example, all of those services that I'm dependent on have to be 5 nines. That's typically the rule of thumb. And so you start to ask yourself, well, are the cloud providers that we have that reliable, or the upstream providers? And the answer is typically no. So then you have to over provision in those circumstances, and that's what starts to drive the cost really, really, really high.
So did I hear you right? If I need to get to 4 nines, I actually have to build my app to be 5 nines. I have to add another digit.
Yeah, you have to build your dependencies for that service to be 5 nines, right? The things that it's relying on to achieve those 4 nines.
It partly also depends on how you're organizing everything, right? You can have a service that depends on another in a traditional sense, and then what you're saying is right, but also a service that calls another service can have internal caching in case that the other one fails, and mitigate that. So it depends really on architecture as well.
It's a little bit of an idealized example, but if you're talking about pure latency, think about, just as an example, the homepage of Google. When you do a Google search, I think that fans out to probably 100 different services, right? So if Google is expecting that search result to return within, let's say it's expecting it within 50 milliseconds, if any of those 100 dependencies takes longer than 50 milliseconds, right, your tail latency is going to define the latency of that service. And yes, you can do things like ignore the response and whatever, but now you got to build a lot of architecture around it. So the more dependencies that you have, typically the tighter the tolerances you have to have on those dependent services.
So if we're loading up the Google homepage, they're probably not including 75 tracking embeds on there.
No,
not really. Yeah, right. But normal companies do.
Yeah. Oh yeah.
Right. They'll have all that extra tracking. And it's like, okay, we need the 4 nines, but we have these dependencies on these 75 different trackers we're going to have on there. Then they're not. Look, we all know this is a big pain, and we also know it's sort of a big lie as well. So, if we're building modern software today, in your opinion, Brian, how should we be building it?
I mean, that's a broad question.
I know. But it seems like instead of distributing everything, this is where monoliths come back to play.
I think there's certainly a time and a place for monoliths, but you get a lot of benefits in terms of how developer productivity by going to more of a microservice-based architecture. Sure, you're bringing in more API services, you're bringing in things like network latency, et cetera, but now I can deploy. And we do this all the time. Like, you can deploy one little piece of the application without touching the rest of the running services, right? I think it's just a trade-off that everyone's accepted at this point. Yes, there's more complexity. Observability is a harder problem. But I think it also creates more of a need for some of the tooling that we provide around, like SLOs, for example, because you are creating a little bit more complexity and dependencies. But it's a conscious trade-off that we make, right, for productivity.
Because I could argue that if I go back to the Google example, you said 100 services, right? If one of those 100 fails, I'm likely still going to see Google search page.
That's right. It's probably just not going to wait for that, whatever that one is to respond.
Exactly. Maybe it will not show me ads, for example, but it will still show me search results or something like that, right? Now, if that's a monolith, if one fails, and that's the only one, there is no way for me to recuperate, to have a good experience with that.
Yeah, you're absolutely right. And I think the other thing that a services architecture lets us do is more gracefully handle those failures. When a service fails, we can, back off requests. We can, we have all sorts of techniques in the tool belt at that point. And I think, if I think back to building software in like 2012, 2013, before Kubernetes, and what it took to support that running typically in VMs on a host versus what we're able to do now in a Kubernetes environment, building everything into decomposable services, like, I would never want to go back to the monolith. There was just so many more problems that we don't even think about today.
That reminds me how I often get irritated when people tell me Kubernetes is too complex. And it is if you're not using what it offers, right? But I dare somebody to go back to 10 years or 15 years to the monolith and do the same thing that Kubernetes is doing today without it.
Right. Try to do blue-green deployment or canary deployments on VMs. You're very quickly going to be building a control plane that looks very similar to Kubernetes. So yeah, it's sure you can do these things, but it's we kind of take them for granted now. But there is that trade-off of yeah, you know what? There is a little bit more magic happening where sometimes things fail and we don't exactly know why because you have software that's running the show and you might not know exactly why it's making the decisions that it's making. I can think to some of the complexities that we've had even in our own application that are very, very difficult to debug, like race conditions, things like that. Especially when you start throwing Kafka into the mix and other things, you can get some very odd results sometimes. So yeah, there is that level of complexity. And what I've seen organizations accept that complexity, but then they also want to measure to a level that they haven't had to measure before to be able to make everything work.
Do you see people pushing back when they're setting up their SLOs? It's like, this is just too much data. How do we make heads and tails of this?
Yeah, I don't think the pushback is around too much data. There certainly is a learning curve. The pushback is more around, okay, like I'm not an expert in writing Prometheus queries, right? How do I get to the data that I want to use in this SLO? And that, I think, is a great opportunity for platform and SRE teams to go out there and work with developers to help them I think just achieve better results when it comes to reliability. We see a lot of companies that have structured SRE teams that kind of look like platform teams, and their mission is to make the services more reliable. And what better way to do that than to help folks focus in on the signals that tell them the most about the reliability of the service? And that's really what SLOs are. SLOs actually help us go from maybe we're collecting a million different time series or signals about our service and reduce that down to the 3 ones that are most important, that tell us the most about how our service is operating for customers, and then focus in on those. The only other way to do that is some sort of AI ops voodoo magic to try to look for abnormalities, and I haven't seen a single solution that does that well.
You just said a lot of magic words there that my eyeballs just rolled back in my head. AI ops, don't get me started. I think it will come true at some point. I believe ML ops is true today, and I would have to guess that Noble 9 is to an extent ML op-ish. Right? Just ballpark. But not AI ops.
Yeah, I mean, I think that there's things that we can do with the data that we have today that are using some basic statistical analysis and probabilistic analysis. And if you want to call that ML ops, like that's fine. Can we throw an entire data set of Prometheus at a machine learning model and say, tell me when my service is degraded to the point where it's impacting customers? I don't think that we can do that today. And smarter people than me are sort of on that boat. So,
and even if somebody or something will tell you when your service is degrading, that's just detection of an issue, right? We will still be missing. Okay, what now?
Yeah. Now the cool thing with SLOs when you start to look at error budgets. So this is the piece of SLOs that we haven't really discussed yet, which is when I talk about how much unreliability I'm willing to accept. This is effectively a budget of how many errors I'm willing to accept over a certain time frame, and SREs call that error budget. When I look at error budget and how quickly I'm consuming that error budget, I can start to do really interesting things with that. For example, if I'm slowly burning error budget, maybe it's at a level that's imperceptible to any given customer, and this is pretty common, but it's at a high enough level that overall, over the entire cohort of customers, it's impacting the overall experience. I don't have to page somebody over that because there's really nothing that I would want somebody to do. It's like not an acute outage. But in our case, we would create a P2 ticket and assign it to the mechanic on duty and say, hey, not urgent, but if you have some cycles over the next week, take a look at this. We're burning error budget a little bit more quickly than we want to. That's not something that you can really determine just by looking at a latency histogram, right? Does this matter? I don't know. But if we look at error budget and error budget burn rates, it tells us very quickly, is this something we should page an engineer about? And what we do in our solution is we actually look at essentially a 1x burn rate means you're going to burn all your error budget over the period, and that's fine. If you go up to 3x, it means that you're going to burn it in about a third of the time. That might be a problem, but it's not necessarily an outage. If you go above 3x, like 8x, 10x, that probably means some customers are experiencing really poor performance, and someone should look at that as soon as possible. But you'll notice that I didn't say anything specific to the service that I'm measuring. These concepts sort of transcend how that individual service is supposed to operate. So now we can have a conversation. Oh, how much error budget are you burning? How much error budget are you burning? I don't need to know anything about your service to know whether you're operating in a fashion that's reliable.
What happens when you burn the budget?
So it's interesting. I think that is something that depends a little bit on the maturity of the organization. I can tell you inside of Google, for example, where these concepts originated, if you just burned your error budget one time, probably not much would happen. If you maybe for 3 months in a row ran out of error budget, someone would look at that and say, seems like probably we're not hitting the goals that we set for ourselves in terms of reliability. Let's stop feature releases maybe for a month and work on burning down some tech debt that we think could improve the reliability of the service. That's effectively a policy, and a lot of organizations are starting to roll out error budget policies. Some are stringent, some are not stringent, just guidelines. But what's interesting is it tells you how much unreliability your customers have experienced over a period that you've defined. So you could say, well, what causes unreliability? Typically, rolling out new features, right? New releases, things like that. So one of the things I can do if I've been through a period of unreliability, I can pause feature releases. So maybe you have a continuous deployment system set up, and we've seen this with a lot of folks. Once a service runs out of error budget, continuous deployment turns off except for bug fixes and tech debt. It turns off for new features. And so we say, okay, we're going to actually give ourselves some breathing room to try to get back to where we want to be from a reliability standpoint, and then we'll start rolling out new features again.
I know that's how it works in Google and really advanced, mature companies. I'm still wondering how much that is in reality really working in slightly less advanced, because there is always a fight kind of like, hey, we don't want to burn our error budget because that directly affects our revenue. We do not want not to ship new features because that directly affects our revenue. So
right.
Fight.
Right.
Like, who wins?
But now you can make decisions with the data, right? And you think about an engineer on the ground that is basically getting pulled in two different directions. At the same time, you're saying, go faster, release these features. Customers are waiting for them. At the other end of the spectrum, you're saying, this has to be 3 or 4 nines, right? Those typically are in direct contention with each other, those two goals. And now you have data where you can say, well, I know we want to do both of these things, but we're doing this one thing really, really poorly right now. So we probably want to take a minute and maybe prioritize some of this tech debt.
That would also, I presume, mean that both the teams and organizations as a whole need to be very mature, right? Because, hey, this is the service that is generating issues, but on the other hand, some other team is expecting a feature and then is pushing you in that direction. So there must be some kind of authority that makes those types of decisions. I presume it cannot be left on a team, right? Because it's a system we're talking about.
A lot of these things do happen at the team level, right? Typically, for services running in an organization, most of them have like a TL, tech lead, right, that's responsible for them. Or maybe there's a director of engineering that's ultimately responsible for that service. And that's where I would say a lot of the power should lie in terms of, hey, we need to back off of something like feature releases. So while I would say that yes, it requires a certain level of maturity, it's a quality of life issue for engineers. And I've seen, I think over the past year and a half, many organizations say this is an investment that we have to make because it's a quality of life issue for our engineers, and because we can't just keep jumping from incident to incident and expect the situation to get better. It's like doing the same thing over and over and expecting different results is the definition of insanity. And so we see a lot of organizations that scaled, maybe they moved to microservices, and they are just hit with a lot of incidents, right? One incident after another incident after another incident, the pagers going off continuously. Say, how do we get a handle on all of this? Well, it starts with accountability at an individual team and an individual engineering level, and having the data to make those decisions.
Does that mean that that would result in more self-sufficient teams? If you go back in time and you say, hey, I develop, you operate, I presume that then that wouldn't really work, because then we have split responsibilities, right?
It actually works in both cases. So if you think about the I develop, you operate model, if I'm going to operate it, you can't be throwing new features on all the time that are breaking it. I don't want to be getting pages all night because you keep releasing buggy code. So the SLO effect is like a safety valve in that circumstance where, okay, we're going to come together, we're going to agree on what reliable operations are, and if we're breaching that continuously, we're going to slow down feature releases because that's not fair to the operators. On the flip side, if I'm developing and operating at the same time, I actually have that same problem, probably because somebody above me is asking me to go faster than I want to, or I don't have time to work on tech debt. I've talked to many engineers in my own organization that say, we really, really need to refactor the code around this API. Like, it's pretty flaky. And I say, well, what's the actual customer benefit if we invest 2 sprints in refactoring this API? And there's no actual tangible customer benefit, right? There's nothing that I can put in a blog post and say, hey, we refactored an API. But when they point at the SLO and they say, well, look at all this error budget we've consumed over the last month or 2 months, and this is actually going to bring us back down to a level that's acceptable. That makes sense to me, right? I can understand that as a product manager.
That sounds as a good negotiation type of tool, right? I know many cases where developers simply are constantly want, but are never allowed to refactor, improve, and stuff like that. So that can be kind of justification in a way, right?
Absolutely. And I think if you talk to Alex Hidalgo, who wrote a whole book on this, he would tell you that the number one thing that SLOs help you do is have a conversation between different groups that have maybe competing viewpoints. And it's a phenomenal tool for having that conversation. And even if you don't do any of the error budget policy stuff, even if all you do is create SLOs and review them as a team on a monthly basis, you get tremendous value.
Do you need SLOs for that? Can you just theoretically review the data and say, hey, average this or that was like this last year and now it's like that? We are obviously not going well, kind of even without SLO.
What the SLO does is it encapsulates how it's supposed to operate. So we got together ahead of time and we said, this is what our expectations are from a customer standpoint, right? That's now encapsulated in the data that we're discussing. So you have the sort of the added context. And then typically it's something that is important to more than one team. And if I'm going to go develop maybe a new service that is going to take a dependency on some existing services, which we all want to do, right? We all want to reuse services and reuse code. The first thing I'm going to ask is, how reliable does the service that I'm creating need to be? And how reliable are the dependencies that I'm taking? And that holds true not just for things that are internal, it holds true for external dependencies. So Obviously, like as a software company, we have external dependencies all the time. We set SLOs on all of those, right? We can't expect our internal customer journeys and whatnot to be more reliable than those external dependencies are.
How do you prevent people from just taking the current bad state, declaring this is SLO? This reminds me in a way like years ago when Sonar Cube became popular, and then everybody discovered that 20% of the tests are failing on average all the time, which is obviously unacceptable, but that became kind of a norm. Hey, we cannot go above 20% failures.
Yeah,
So
yeah.
I guess many companies will also, when they discover, probably many do not know, but when they discover how bad they are, how do you prevent that becoming a norm?
Well, I mean, I would say if you're achieving this level and customers are satisfied, then what's the problem with it being the norm? At least we have a baseline at that point. If customers are not satisfied, if we know that reliability is an issue, then we're going to have to tighten these goals over time. And that's part of the practice of SLOs is when you review them, typically you're looking at them on a weekly basis if you're directly responsible for operating a service, but you're also reviewing them quarterly with different stakeholders to understand if these are the right goals. I would argue too, if you set a goal, let's say we set like a 3 nines 500 millisecond latency goal for the response time of an API, and I'm always meeting that, that's interesting information too, right? If nobody's ever had an issue, well, let's say for example, I'm always failing that goal, right? Let's say for the entire month I've been at 700 milliseconds, but nobody's ever raised an issue about it. Okay, well, that probably tells me that I can actually relax that from 500 to 700 milliseconds, right? So there is a little bit of an art to it, and there's a discussion that has to happen between these stakeholders.
Well, with these stakeholders, one of the things you said earlier was how the error budget is supposed to operate. Let's assume that 3 months ago we came together, we agreed upon the budget, and now we're today, and of the group, one person does not remember that conversation or remembers the conversation being something completely different. And this person also signs the paychecks. How do we deal with that?
Well, I'm hoping we took notes in this meeting, but barring that, when we create the SLOs, typically these are something like a service definition. In the case of our software, it's something that you would define in a markup language and check in. All right, so you have something that you can go back to and you can say, well, you may not remember this conversation, but we had it, and here's the artifact that we checked in that everyone approved. So if there's so much cognitive dissonance that doesn't help you, then it may be time to look for a new job. And I think everybody's hiring SREs these days. But the nice thing is that it does operate as something of a contract or an agreement in terms of what everybody had a vote in this, and now we at least know where we are. And I would add in situations where a company is providing an SLA, if you aren't using SLOs, I would really question how you're managing to that SLA, because you have an opportunity with SLOs to create goals that are tighter than your SLAs. You don't want to always be up against the limit of your SLA because you're going to violate it all the time. But beyond that, an SLA probably doesn't tell you much about customer happiness, right? It's probably set to be as loose as you can set it, because it's a contractual instrument. So, as somebody who builds and operates software, like I think we want our software to operate to where our customers are satisfied with it, not to where we don't have any financial penalties.
Did you ever witness a case where SLOs contributed to some people starting over with something? I mean, we spoke about refactoring, right? But sometimes you have those old, ancient stuff that not much can be done to help, right?
Yeah.
And nobody wants to replace them because the work is simply,
Yeah. I think in those cases, the SLOs are helpful because they give you an understanding of where those cracks are in your overall user journey, right? If you have a system that has a dependency on an old mainframe that is just very slow, and you put an SLO on that, well, now you have something you can point to. You say, well, we can't meet this customer experience goal that we have in this other system because you can see how we're performing with this particular SLO. So then you have, I think, some data that can help you target that for investment. And that's what I've seen happen more than just using it as an opportunity to throw things out. But also I've seen them used in sort of cloud migration scenarios, or even going from like the monolith to the microservices, because you can create an SLO. It gives you some baseline around performance, and then as you start to shift traffic or resources or whatever over to the new system, you can see how that new system performs with respect to the SLO.
Will that SLO change if I'm moving from system A to system B?
I would say that it wouldn't change unless your customer expectations changed or your risk profile changed, right? The SLO is a description of what you want to have happen, not necessarily, it doesn't depend on what is the underlying technology that's delivering that.
So another way to say that, I guess, is if your error budget goes up, you did it wrong.
Yeah.
If your error budget goes down, that's not a bad thing. It should be at least the same.
Oh, absolutely.
It's like writing an interface, right?
Yeah.
If I'm doing Open API, my API is not going to change. I can gut everything behind it, but that API is the contract.
Yeah. And I think the other interesting thing about error budgets are we actually want to consume that error budget. It's actually dangerous from a resiliency standpoint to have services that were not designed to operate perfectly, operating perfectly, because other systems become dependent on that. And there's a very famous case from within Google where there was a service that was not designed to be highly available, and every other service had designed it in as a dependency, and it became a huge risk because this was not staffed to be highly available. And the solution that they actually had to make sure that folks weren't actually depending on that service because nobody wanted to invest in it was to actually pull the plug on it for a couple of hours a month and see what failed. Basically, there's you could say chaos engineering, like you can actually force yourself to consume that error budget, and it's actually a really good practice when it comes to reliability engineering.
Boy, that just sounds scary in all sorts of different ways, but it makes total sense. So as we're starting to wrap up, again, you're the chief product officer, operator, bottle washer,
sure,
officer, whatever the right
I'm
one is.
I'm the product guy. Yeah.
You're the product guy at Noble 9. So how do you set your error budgets?
So we're perfect when it comes to error budget policy and everything. No.
Yes.
So no, it's an iterative process. Typically, we start from identifying the customer journeys in the product that are important. Myself, our product managers, our product owners will get together and brainstorm with UX. These are if I'm using the product as a customer, these are the things that keep us up at night, right? If this isn't working well, so like for example, within Noble 9, if our charts aren't loading quickly, that's a problem, right? That would make our users pretty annoyed. So I say to the engineering team, look, when I open the details page of an SLO, I expect all the charts to load within 2 seconds, 99% of the time. Say, okay. So then they go find the telemetry that we have for page load time or for the charts loading. And it's not always obvious where it's going to come from, by the way, but you find the right API, the right interface, and then we create an SLO out of that. And then on a roughly monthly basis, so we'll create alerts around that SLO. So like if latencies are spiking on charts, right, that SLO will burn a lot of error budget. Somebody will get paged. But then on a monthly basis, we're looking at it. We're saying, are we sort of meeting our goals there or not meeting our goals there? And interestingly, with that one in particular, we actually were consuming error budget at an elevated rate to the point where we felt like it would impact the customer experience. And we actually found an external dependency that was causing that. We went to that vendor and we said, look, this is what we're seeing in our SLO, and you're the culprit. This is why. And they said, you know what, you're right. They went and fixed the issue that they had, came back to us, and you could just see our error budget start to recover after that for that particular user journey. So we repeat that for backend services, front end services, customer user journeys, and over the course of time, a couple months, 2 to 4 months, you start to get a really good picture of how you're actually, how you're operating overall from a reliability standpoint.
Okay, another question. Should your error budgeting align with your financial budgeting?
I think they're definitely related because one of the drivers of operating margin or cost is spending on reliability. If you set a tighter error budget, or if you set a tighter objective for a particular service, you should expect to spend more on that service. You're going to hire more people to support it because you'll need to have more staff, and you would expect to have, like I said, over provisioning, right? If you want to have a service be more highly available, how do you do that? Well, you probably provision it in more regions, for example. So to go from 3 nines to 4 nines, maybe I had to go from one region with 2 availability zones to 2 regions with 4 availability zones. Maybe I just quadrupled my infrastructure footprint, right? I mean, they're definitely related. I don't know if you can. We actually have had a customer that has an SLO set on the spend, hourly spend within their cloud environment. So if they start to spend too much, it actually starts to burn that error budget more quickly. They know they have something to look at. So you can link them sort of directly, but I would just say mostly it's more of a correlation.
So all of Brian's contact information are going to be down in the show notes. So Brian, if people wanted to get in touch with you, what's the best way to do it?
Come to our website, www.noble9.com. You can sign up for a trial. You can get a demo. You're also happy to welcome to email us, hello@noble9.com. I'm also on Twitter @Brian_Singer. Feel free to tweet at me. And yeah, love to help out anyone that's interested in SLOs and error budgets.
And Noble9 is NOBL, the number 9.com.
Yep.
Brian, thanks for being with us today.
Great. Thank you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.